All right, guys. Hello. This is Mark here. We're going to do a webinar. And I don't know if you can see how many students there are, but I can, and that's not many, which is exactly my point. What I will do then is I will allow everybody to talk so that if you want to talk, you can. Okay. Because we will not have such a crowd of voices. We'll be good about that. There you are. Of course, if you want to silence yourself, you're welcome. But the discussion in informal style, that's what we usually do. At least that's what I usually do. So you guys see my screen and you can hear me. Could you confirm that? Like if I go to the chat. Yes, all right, excellent. So I see this, yes. And I'm saying thank you so that we have the communication going on. All right. So I'm starting, and I know we're recording. So later on, if somebody needs a recording, we will get the recording. I cannot promise that I will be watching what you're texting because I'll be looking at the slides. Instead, however, and I see somebody else joining in, I'm letting that person in and allowing them to talk. So instead, speak up. If you want to say something, please do that. I'll go and open the first thing that I want to open. So what I have to show you is, first of all, the general idea of why we're so few. We're not that many here. And then I'll also show you what to do about this. So here is a little spreadsheet that lays the ground to what we're going to discuss. Well, it should open, right? And here it is. Now that's a little bit too small. But if I double click, you can see that, and moreover, I want to do it in a little bit bigger way. So here it is. No, doesn't let me do anything. That's okay. You don't really need to read it. But I'll tell you what the problem is, and then later on, I will also tell you what the solution is. And here's the problem. You have hacking. Now, how many people are curious, at least curious, if not excited about hacking? Can you like raise your hand if you are? And as an example, I will raise my hand to start with. If I can only find that place where you do this, then I will raise my hand. So, okay, we have one person. Well, assume we have more. You just guys don't want to betray your secret hacking personality. And by the way, talking about this, there are ways how you can be a secret freedom fighter or hacker and not go into prison for that. And if you're interested, send an email. I'll give you a YouTube. That's a famous YouTube, how not to get into prison for being a freedom fighter. It's a few years old, but basically he teaches how to create a persona, how to create your own, but not your own, representation on the web. And the major law is never to be sloppy, because there is only one chance to be sloppy, and that's it. So if you're not sloppy, and never log in anywhere, not from your own computer, but you're always covering your tracks. So that's a good idea. Now that's for hackers. For us, we're developers. I assume we're not really hackers, just curious. So the game is completely the opposite. If you're a hacker, and that is explained here, then you get a good pay if you hack. Now, if you're a developer, totally the opposite. You're not getting any rewards ever. You only get blamed if you are hacked, and nobody praises you if you're not hacked at all. Well, I want to change that, seriously. And what I want to do is offer the world an actual system make sure that we, the good guys, that we do better and better, and that we build secure systems. Now, I'll talk about specifics, Vault and Consul, but that's the basic idea, to help people build more secure system. And the first point is that, look at how few were here in the meeting. Well, because developers are not really paid for making anything secure and not rewarded. I'm not paying them, but I'm proposing at least a fun system where they will be getting bragging rights or getting any kind of points or rewards for being more secure. And as people come in, as if to deny the fact that nobody's interested in this security, I'm letting them in. All right, so let's close that. That was a general introduction. And let's open the slides. Here are the slides. They will come up. I'm surprised that they take so long time to come up, but they will. All right, here it is. So what I will do is I will put it into the slideshow mode here. And I reverse the order a little bit. We'll start with Consul. I'll show you why. Why do I start with Consul? It just makes a bit more sense. And here's our life right here. That's our life. We're software developers, we're writing code. In this code, we could have potentially a lot of functionality. Here's an example. Let's say I'm working for a bank or financial institution of sorts. And maybe A is my login. So I wrote an application, maybe even a web-based application. Here's A, the login. And then B says, for that guy, show his balance. And C says, for that girl, do the transfer. And then finally, D is for foreign exchanges. So it's a serious stuff. And if somebody has a bug, then I need to redeploy the whole thing. It's one big jar, if it is, let us say, Tomcat, or if it is a Python application, it's a zip file. So I need to rebuild it. I also need to test it, retest it. And who likes testing? Nobody does, right? So that's a bother, but that's how things are. Now, it's not very good. What I'm suggesting is let's separate. Let's have a separate project responsible for the login with all the complications. It should know what to do. And then B is again the foreign exchange and so on, but I have separate systems for that. And I have separate teams potential working, every one of them, which is okay. The bank can afford it. And even if it's not many people, it is still many different subsystems. Now, of course, you recognize I'm not saying anything new. I'm talking about microservices. So these are microservices. I have broken my ABCD application into microservices A and B and C and D. And now immediately we have a problem. Here's the problem. The first problem is called discovery. When A talks to B here, then it is a nanosecond call because A calls B here in the code. Maybe it is a Java call, maybe it's a Python call, all in memory, very fast. Now there will be a certain latency. Now A is calling B, right? But the question that it has is not only latency. Yes, I need to think about latency, but it's a good trade-off. I'll give up on latency. I need to know where is that B. Up until now, it was right here, do the call. Now this is B. So how do you solve this problem? That's called discovery problem. This is how. You put a load balancer in front of B. So when A wants to talk to B, it issues a call to B and depends upon what protocol we have implemented. So let's assume we implemented some kind of RESTful protocol because that would be the fashion today. So that answered, but I need to also know where that B is. A load balancer has a permanent fixed IP. I'm always talking When I want to talk to B, I'm always talking to the load balancer. And the other way around, A will also have a load balancer in front of it, maybe here. So when B or anybody else wants to talk to A, there is a load balance to talk to. All right, so we have a few problems now. First of all, we have a double latency. But since you guys already agreed to deal with single latency, you might also agree to deal with double latency. And that's maybe okay. The next question is, here's one load balancer, here's another, and a third one. And every subsystem, it's another load balancer with its own IP and with its own single point of failure, SPOF. So that's not very nice. And I need to manage all these load balancers. Let's improve it a little bit. Let's do this. Let's create a registry here on the right. You see a little registry, and that registry is instead of load balancers. So all of those load balancers, they go into the registry. When A wants to talk to B, it first asks the registry, where is B? And it gets back the IP, so it knows who to ask. That's called service discovery. And now we don't need load balancers. I took them away. And every instance, when it comes up, like that, comes up, registers in the registry. And by the way, I got one more additional benefit. When I bring another server to do the functionality of B right here, that also registers. It registers in the registry, and now the registry knows all of instances that are doing B. So I got fault tolerance, I got scalability for free. Now ask me if there is anything that you want to be explained, shorten this question answering cycle. Just ask. Just go ahead and ask if there is any question. If not, I'll continue and you'll get the recording later. I will also get the sources for my knowledge so you'll be able to check and verify, and why would you trust me? So we made that step. We now have the registry, and that is good. But here's another but. It's not only the registry. Just registering my service and telling it what IP I am running at is not enough, because there are also multiple configuration files. So let's assume it's an XML. Today, maybe it will be JSON, but let's assume it's an XML. So it used to be that in this kind of monolithic service, I had a configuration XML. And even better, maybe, that somehow I made it re-ask the configuration. So when I change the configuration, like let's say I want to put it in the maintenance mode. So I go into the XML, I say flag that says maintenance, yes. And somehow maybe my application polls this every 5 seconds. And so I go into the maintenance mode. Now here I have multiple components, and every one of them, you see this one and that one and that one, every one of them has its own configuration file. So that's a bit too much, right? So what we can do is we will add one more component, like here, KV, key value. So if I add one more component that will do this for me, then I have flattened my XML files. I have flattened all my configurations files. And again, not necessarily XML, maybe JSON, or maybe just break it out into key value pairs. And life is easy. And make that a NoSQL database and ask somebody to do that as a service. So now, if I want to go into the maintenance mode, I change that value. For every component, it goes into the maintenance mode. Not only that, it can start up in whatever configuration I'm telling. So we got that, and we got some persistence between runs for my system. So I can even run different versions, switch to a different version. It's getting a little bit hairy, a little bit more complex, yes, but that's the direction of life today. And if you don't believe me, I'll prove that point later on at the end. So we're doing this, and it seems okay. Well, there is one more but. And this one more but is security. So up until now, here we are. We had this monolithic application. That was our bank. And maybe it had the load balance in front. So that load balance was the security term called ZMZ for the anybody can hit there. That was the open season on me, but I was prepared. I was right here. That was my security boundary. And then come the application. Not everybody gets to that application, but only those people who come through my filter. And now they are here. That's how it was. At least it was reasonably simple. And then the data, well, I could afford to hide the data even more. Okay, so 3 tiers, but very clear and very well understood tiers. Look at what's going on now. So here on the right, I have my system. Where is my entry? Well, everywhere, right? I can enter into B, but I can also enter into C, D, A, whatever, right? So I have very many security layers and boundaries, and I will have to protect all that. So that's the question that I'm asking now. So what do we do? Well, the answer is right here. Just one more layer and will be good. We're almost there, guys. So I have the registry. That's where every component now registers. We have the KV, we have the configuration, the key and the value pairs. And now we have something called segmentation here, the standard term in segmentation. Now on the right, that's why I'm drawing up the implementation. So no hiding, that is Consul. Consul is software that implements all of that, all of my concerns, and these are common concerns. Whenever you're doing this kind of thing, you need discovery. You need to know where's A, B, C, and D. You need configuration that will tell me where the parameters for my systems are. And segmentation is, well, how do I break that simple but incorrect picture? How do I break it into more? So the answer is that I need to somehow do a security, put it in. However, I will gain every time that it's a bit more complex. Every time I actually gain something in return. The problem here on the left, the problem was that I assumed that nobody can get here other than through my load balancer, and only the good guys get in there. Therefore, if the bad guys get in there, well, it's game over. Because I trust here. It was too hard. 10 years ago, it was too hard to me to think about security, but not trusting yourself, kind of. And that bites back. If you do your architecture this way, once you're inside, you're the king. That's what happens to Apple. They filter all of the developers extremely well. But once hackers are persistent and they get inside, now Apple, in fact, protects them from being detected. That's aside. We're going back. Here we are. I described the common concerns of discovery of services, configuration of parameters, and security within. That is called segmentation, and it's done by Connect. But let me show exactly what the solution looks like. So the problem that this Connect and that this segmentation need to solve is this. Let's say A is a login, and it puts me into B, the screen that shows my checking account. So A should be allowed to talk to B. But look at our picture. We don't have A. Instead, we have A registering itself here as an IP. So I got an IP from A. I got maybe multiple IPs from B. So even though my rule says very simply and straightforward, A should talk to B, but the truth is it's a lot of IPs that can talk to other IPs. So how could I simplify that? How can I express it better than, let's say, 50 IPs talking in 5 components, 250 entries on the table, which says what's allowed, what's not. Here's what we do. We put a proxy in front of each one of them, and we protect that proxy with a certificate. So now when A talks to B, it doesn't really talk to B. It talks to a proxy through the TLS. Let me show you what I really mean. That's what I really mean. So here's what we do. When we want to say that A is really A, well, we don't let A talk to anything but the proxy. So that's pretty hard to hack that part of it. And that is how A really knows that it is A, and also B knows that it is A, because it's not talking to A, it's talking to those proxies. Proxies are mine. I implement them, meaning Consul implements them. And now I can go back to my table of A talks to B instead of all IPs, because I add that picture to my console. So I will have TLS certificates, and those certificates will give me the guarantee that A is A and that B is B, because it's authenticating mutually. A knows that B is really B. B knows that A is really A, because both of them present their certificate through Consul. That's how we enforce that, right? Now we have a set of proxies. Yes, true. But the advantage of that is that each proxy has a certificate and authenticate. That's called mutual authentication. You'll get other advantages kind of for free. For example, let's say you have GDPR regulation, you're in Europe, you want to enforce that. Well, the answer is that proxy knows about it. Proxy can make sure this is true. Another thing is that you may have heard about zero trust network. Here's what I mean. This is not a zero trust network. That network trusts a lot. It trusts that A is A, that B is B, that A is allowed to talk to B. So instead, we're doing this. In this form, I have a table. That table was in the registry. And it said A is allowed to talk to B, and enforcing it is done through proxies. So again, if that is something you will know, then great. We're just preaching to the choir and you know the same language. But if it's something new to you, then it's worth learning about this, because that's where the world is going. Okay, I'll tell you how practical and humanly we're going to organize that. Now they all talk, and they also all discuss what is allowed to be discussed, because the proxies, they take care of that part. So finally, we come to this. That's called the service graph. Now, A can talk to B, and B can talk to A. And the fact that this is so is given by the service graph. So that's where you, the developer, you're writing these rules. And proxy, with the help of the console, implements it. That's awesome. So altogether, this is what is called the service mesh. That's a popular term now. There's an open source project for service mesh. There is Istio. That's one of the service meshes. That's what Google uses for their own service mesh in the component called Anthos. We'll talk about all of them. But I was talking to some people who much prefer the Consul implementation of the service mesh than Google's implementation. So both, of course, you can't argue too much against Google either. Both have a claim to life. And now we have our component. That's the final picture. I promise you we'll come to something. And that's what we have come to. So that's an implementation done by Consul. Let me pause right here and ask you if you have any questions.
So can you explain more on the zero trust network?
Yes, I'll be happy to. So what is a not zero trust network? It's this picture on the left. Here, A talks to B, and it trusts B because they are within the same network perimeter. I protected this. It's my internal network, right? So we're familiar with this picture. No question about A knows that B is B because it says, well, who else can run inside of this network? That is a VPC, virtual private network. Now here, A is a separate thing from B. It might be running in the same data center. It might be even running on the same computer, but it never assumes that just because you're running on the same computer in the same data center, that's the reason to trust B. That's not why A trusts B. Rather, it trusts B because B has a certificate issued by the certificate authority, which confirms that it is indeed B. That's authentication. So zero trust network is this new popular term, which says let's build something that doesn't depend on components trusting each other just because they are within a certain network perimeter. No, they trust each other because each one of them presents a certificate that is trustworthy. The way this is organized is by running through the proxy. That's the enforcement of it. But the whole idea, you see, zero trust network is not a specific component. It's not a, how should I say, system, but it's a whole design pattern. Was that your question, Jan?
Yeah, you answered my question. Thank you so much for information, sir.
Great, thank you so much for asking the question. Any more questions? All right, let's continue a little bit. So this is done. If you're familiar with big data, you probably heard about Zookeeper. So if you want to compare, the first comparison that comes to mind is Consul. Now, Consul is more popular. It's an open source thing. And there are another few reasons why you would prefer today to do Consul and not Zookeeper. Both of them are very fast, both are in memory, but they are for another purpose. You could build your Consul on Zookeeper, but you would have to add a few things. So let's assume we go with Consul implementation of this idea. Now, the next thing is that I told you that Consul, you can compare it to Google Anthos. So what is Google Anthos? For that, just Google Anthos. Google Anthos. And you see what it is. Anyway, it's Google's claim to fame. They take your software and they wrap it up in this new framework called Anthos. Part of this Anthos is exactly what we were talking about, the service discovery, the security. So the idea is that here's your secure framework, dear programmer. Let's take the load of hard work of security away from you, put it into the system like Anthos or like Consul. In other words, hire the truck and hire the movers with that. Let somebody do that work. Now, of course, you'll still have to do a few things. In case of moving, you'll have to package. In case of Anthos, you'll have to have your computer load your implementation in microservices and maybe even in Kubernetes. But, well, that's where you might want to go anyway. So either this or that, you need to look at the implementations. And here we see that Consul is actually even more popular. Now, so what this Consul is an open source component from HashiCorp right here. And that's one of the reasons if you want to go with the open source part of HashiCorp, and that's a big thing, and no pay, then you can. Consul is not for faint-hearted, so I'm not saying that's where you should run right away, not at all. But it is something which I believe represents either the future of implementation or the idea of the future. So that is Consul as a system. And I wanted to change the word. I said, let's look at Vault first and Consul next. But I think Consul gives you a better idea. That's the view from the top. That's better thing. And by the way, I think some people left. which again supports my idea. My idea is that developers don't want to do it. They want to do features, they want to do startups, they don't care about security. Who should care about security? Well, there is a wonderful article just recently by one of the chief advisors there. I got the name, I can give you the name. His major thought is that you have a company, that's who does software. Usually it's a company. And the company is rewarded for the results, not for security. So there is a big push into forget security altogether. The only agency that can change it is some law, some government, something. Because if not, well, the current state of affairs is that the United States is an open season for Russian hackers. And I should be careful saying such things because I'm a Russian derived United States citizen, right? But that is the story right now. So developers won't do it, except unless you are this security champion. People like to say that these are the roles, security champion roles. So if that's what you are, you have a great role to play. But I believe security is coming into its own just right now, just because of all the hacks. I don't have to tell about them. You know, all of Ireland is without healthcare because of the Russian game. That's a good example. I think they gave it the keys, but now it's very hard to bring the system back up. In any case, let's talk about that was the view from the top. Let's look into more security that you'll get those slides. You'll see whatever references you get, but let's talk a little bit about Vault. So Vault is modern approach to security. Again, everybody knows that they should encrypt their database, right? But not everybody knows exactly how. They heard that, encrypt your database. So Vault is an open source component. It runs. If I just go on the command line, let's say command line, right? And I say Vault, and Vault is right here. Tells me here. So that's an installable open source component. What it does, and here's an introduction, what it does is it implements a few dozen of different security patterns. That's how you should be doing programming. Now, the story was then the HashiCorp guys who are very smart. The two founders are just brilliant. Watch their lectures. So when they were doing their Terraform, first of all, and other things like that, more and more people were liking it and relying on this, and they were becoming the hub of storing confidential and secure information. And they were very nervous about this. They needed some secure component. They didn't have any. So what they were looking for was Vault, but they didn't have it. So now they started looking around at different places and the security situation in general. And they saw that people have their certificates, they have username, passwords, and they store them in a pretty bad way. For example, if I'm using my own personal security database, that's KeePass. So I'll go to the command line and I'll store perhaps my database here. I'll be able to open my database. And once I open with hopefully a secure password, and what? It doesn't want to open. Then I have what? 347 different passwords here. All right, that's a good solution, but not an enterprise solution. It's for my personal needs there. And it at least hides the passwords. So nice. But they were looking more, they were looking for more security, and they needed their own solution. So they looked at, that's all that they invented, but they looked at Kerberos. Kerberos is a nice thing, open source, that follows a great rule. Your security should not depend on not publishing your code. Publish your code all you want. It should depend on cryptography, and don't publish your key. That's all that you don't publish. Kerberos had a few problems though. Not too many people implemented. And that is, they had to bow to Kerberos. In order to implement it, your systems had to follow the rule. So they took the Kerberos idea, but they inverted it and they said, now we'll give you plugins so that anybody who wants to connect to us, to Vault, will have a plugin to connect. And here are the plugins for all of the common technologies. Therefore, you can use Vault with anything you want and make it more secure. Let me give you one example. Let us say you have a database. Many people have databases. Well, the database has username and password. So write it down on a piece of paper and lose it. That's the worst practice. The next one, write it into the text file and store it on your computer. We know how bad is that. The next one is store it as a secret, encrypt it in Vault, and Vault allows you to do this. That's much better. But somebody else will write it down on a piece of paper and lose it for you. So it is a secret as far as you're concerned and Vault is concerned, but the world knows all about it. The next one, ask Vault to automatically rotate those credentials. So whenever you, as the developer, ask for the username and the password, Vault gives that to you, but it says, aha, next time won't work, I'll change it. That's one design pattern that implemented in Vault. And if you just give it a little time, you'll appreciate the power. I don't know if I have the slide here. No, yes, I do. There you are. That's my sad situation on Amazon. I should be rotating these keys. I'm not rotating them. Amazon flags me. And they solve that problem by rotating every time you use it. All right, but I'll give you another good example. Let's say I want to send some secret somewhere else. So now I'm nervous they will intercept my communication. I'm sending the secret somewhere. So what I can do now is I can wrap my secret. I'll put it into Vault. And I will send the place where that secret is stored in Vault, but not the secret itself. So what then happens is that somebody gets that and they need to get the secret by getting into Vault. But the secret stays a secret. So that is number two. How do I preserve my secrets? And on. They have all the plugins. They have all of the, what I would call the best practices or design patterns. So if you have a problem, you're thinking, well, how did Vault solve that? I don't advocate Vault necessarily, but it would be one of the sources for design practices. What I do advocate is use a secure framework. And Vault is one of these, and Consul is another. They solve different problems. That, I think, is as much of advertisement as I wanted to put in. So the benefits of Vault, you now know. You can get support, that's going higher and higher, but the result is this: you can solve most of the problems. Now we'll go through the problems, which I already explained. You want to encrypt something? Well, ask Vault to encrypt it. Again, that becomes encryption as a service. That's the second point where I'd like to pause and see if there are any questions. No questions. So what I'll do is this: I will congratulate you guys on staying with me for so long up until now, because that's the future. You know, everything will be hacked, but those people who are protecting, they won't be, at least not the first targets. And so today people don't pay enough attention to this, but I'm sure they will. And I like that we're few. That's the proof of that point, that we are those who are beginning to understand how that is important. So that's the story. You can ask questions now. Vault is now a service running on Amazon, so you can just run it there. Instead of making it a multi-cluster, because your complete application now depends on it, and maintaining this cluster, as of April, you can even get it from Amazon, probably other clouds as well. So great, I'd like to thank you for staying with me. I'd like to also point out you'll get emails, you'll get recordings, you'll get these slides so that you can go through that. All of that is open knowledge and open source, but there are lots of things that people talk about today, and it's hard to figure out what's right, what's wrong. So I hope I'm giving you what's right. Giving you just a bit more time to ask questions and then letting you go.
Mark, I have a question.
Yes, please.
You say the Vault is available on Amazon Cloud right now, and
Yes.
so is there like a different package or plan for the fee for?
No, that is also free in the sense that the software itself is free. However, Vault is available on the cloud. Here's what I mean. An actual running cluster is available on the cloud. So you can start by running Vault on your local machine, and that is, of course, how you will start doing your own implementation. And now that your system is working and it's storing its secrets securely, and I don't know your situation, I was teaching it to a group of developers at Unisys, and they were showing it to their client, and the client was more and more happy by understanding what they were getting with this new security architecture. So the client wants now the whole system to be on Vault. And now that they want it on Vault, you want that Vault to be up all the time.
I see.
The way you run Vault is that you run it in the background, that's a service, plus you do the commands. But for that, your Vault needs to run all the time. That's what Amazon gives you. It gives you a cluster that doesn't go down. What it does cost, because that cluster runs on services. For the price reason, you might still want to run your own, even in the cloud. But that's where we are, and that's in the area of implementation and fault tolerant implementation.
Okay. One last question, Mark.
Don't worry about last question. Let's keep talking.
Okay. In terms of tech support for Vault, is it during office hour or 24 hours a day? How does it work?
That's a great question. Well, Vault is by HashiCorp, and I told you I have nothing vested in HashiCorp. But I do teach that stuff. That's how I come in, and not on their behalf, but on whoever is interested in training. Now, if you want support, you can get support from HashiCorp. That is also a very popular open source. So just like you would use any open source, what would be the example? Trying to think something comparable to that. Let's say Spark, maybe Spark for processing. So would you want support from Spark? Well, you can start on your own, right? It all depends upon the environment and how much your client is willing to pay for the support, but it all exists. You can get support from HashiCorp. You don't have to. My estimate is that out of 100% of people, maybe 1% buy support, and the rest do it on their own or some kind of support. Is that what you were interested in?
Yes, Mark. I was trying to find out. I probably have to discuss with my business partner. Like, I kind of like your presentation on the Vault thing. I think is something that we are kind of looking into. Yeah. Thank you for the information again.
Yeah. Thank you very much. And I like it. I mean, you like it because I like it. I like it because it's really a good thing. All right, guys, that was a good note to finish on. And I wish you a very good day.
Thank you, Mark. Thank you, everyone. Bye-bye.
Thank you. Goodbye.